Hello, and welcome to week 12. Um, I had originally planned one of your assignments this week to actually go for a walk to the beach. So that's not happening. What can you do? The reason is because we were going to be talking about the coast, the coastal zone, and how it figures into all of this stuff. So we're going to talk about the features of the coastal zone. So different types of coasts. This is a little bit more of a physical geography aspect of it, but then we're also going to talk about some of the political features of coasts, the economic aspects, and then, of course, as always, the environmental connection between people, society, and the coasts. Excuse me. So, anyway, let's start with the physical. So, we can break down coast in many ways. The first way we can kind of categorize them is if they are what's called a primary or a secondary coast. In other words, how is the actual shoreline created? And a primary coast is created by things that do not involve the ocean or the lake. So they are created by things like sediment being washed down a river and deposited at the mouth of a delta, or glaciers coming out of the middle of Greenland. Things that aren't dependent necessarily on the ocean, which means the secondary coast, and this is a typo, is created by marine activity. So wave erosion. The waves crashing on the shore has carved these cliffs. Beaches, which is basically sand being deposited by sand in the water being laid down. So primary coasts are not created by the water, and secondary coasts are definitely created by the water. Second way we can look at it, and by the way, don't touch your face in public. People freak out about that. Long story. Is the tectonic setting. What is the crust of the Earth like? Now, we've briefly mentioned how the Earth is basically composed, its outer shell is composed of all these different crusts, and when they hit each other, that's an earthquake. When you have two pieces of the crust hitting each other right near the coastline, you have a collisional or active coast, where this crust meets this crust right here, very close offshore. So this shore is an active or collisional coast. So things that tend to happen, the profile tends to be steep. It tends to get very deep very quickly off the coast. And usually you'll see what's called a deep sea trench right off the coast. So, for instance, off the coast of South America, there's a deep trench that runs parallel to Peru and Chile on the west coast. There's also one in the right off the Philippines in the Pacific Ocean, the deepest part of the ocean. So just like the other thing, then the other side would be a passive or trailing coast. And underneath here, if you look at the video, the difference here is that here's the shoreline, right where my pointer is, but the edge of the crust is way here in the middle of the ocean. So here it tends to be a much more shallower uh, ocean. It takes a long time for it to get deep and less tectonic activity. We can also look at the actual makeup of the shoreline itself. So we're going to break it down into two ones: beaches or basically not beaches. And beaches are just that, shorelines that are covered in sand. Now we can break down beaches themselves into four kinds of areas. So if you look at a generic beach, the offshore zone, this is the first part where the bottom of the water becomes shallow enough that it affects the surface. In other words, the waves and the currents that make the waves finally start touching bottom here. And when that happens, that becomes the near shore zone. And this is where waves start to get taller. So I'm assuming you've all been to the beach at some point, and you'll notice that as the waves come closer to shore, they start to grow a little bit, and then they turn that little white and they break and fall over. The foreshore, right here, this is the area between the waves, between where the waves go their highest and their lowest. So that kind of back and forth area. And the last part here is the backshore area. This is the part of the beach where it never really gets wet. So maybe you have sand dunes, or in Chicago's case, a parking lot, right? It's still affected by the beach, and that there's a lot of sand and a lot of blowing wind that affects the vegetation. But this is the most part is the dry part. So from offshore all the way to backshore. Excuse me. One of the ways that beaches are created is called the longshore current and the longshore drift. Most waves hit the beach at a slight bit of an angle. Very rarely do they come straight on because most shorelines aren't straight. And when that happens, the waves generally hit this angle, it forms a slight current in the water that tends to flow one way. So if the waves are coming from this direction, as my pointer is showing, right off the shore, there's this current in the water that gradually moves this way. And which way this goes all depends on the geography of the lake. So in Lake Michigan, in our example, in Chicago, generally speaking, because of the wind and the shape of Lake Michigan, the longshore current tends to go from north to south. So generally speaking, in that, north to south. And that's on the other side of the lake. If you go around to Michigan, Indiana, it actually curves. And so on that side of the lake, the current generally moves from south to north, almost kind of like a circle. But one of the things that this does is it creates longshore drift. So what this means is because of this current, generally speaking, sand gets pushed this way. And it happens like this. This little circle right, you're standing on the beach, right? And the waves are coming in kind of at that angle. So they kind of wash up the beach. That's the swash where the waves kind of break and come up and hit your toes. But then when they go backwash into the water, right? Instead of going back down at an angle, they just go straight down the beach. So generally speaking, the waves are doing this, up, down, up, down, up, down. And what happens is if you're a piece of sand, right, you get washed up this way and then brought down this way. So gradually you're pushed this way along with the current. And over time, that can actually create these huge sandbars. So you can see right here that this wave action here, this is the general current. You can kind of see how the waves are pushing it. And over time, it just pushes sand. Forms this long lick of sand. They call it a sandbar. This is all sand that's been deposited by the waves over time. Creates these islands. Another example is a sand spit. Now here, if you look, here's the land right here. The waves generally are going this way, and it's just been pushing sand up this far. Almost like this little kind of lick of land, right? Now, it usually goes parallel with the shore. This one kind of sticks out. It ends right here because as the water gets deeper, eventually, it's too deep for the water to keep on piling it up, and so it just kind of gradually drifts off. You can see here how it actually gets deeper behind it. Okay, so that's a sand spit, which is kind of like a sandbar. Another one we'll see are coastal dunes. And here, the wind keeps on blowing the sand from the beach inland, and it piles up. This is actually a picture that I took in Indiana, in the Indiana Dunes National Park. If you haven't gone, it's an amazing place. 2 hours from the city, you can actually take metro to get there. Excuse me. But these dunes can be as high as 300 to 400 feet. And what happens is they blow inland. Eventually, they get far enough from the lake, the wind slows down, and it allows grass to grow and small shrubs. And those roots get into the sand and start to anchor it in place. The last formation we'll talk about are barrier islands. And these are basically sandbars or sand spits, but instead of sticking out into the water, they run parallel to the coast. So along the east coast of the United States, from Florida all the way up into Massachusetts, we have this long line of barrier islands. We talked about the Gulf Stream many times and how that flows from Florida along the east coast all the way into Europe. That current helps deposit sand and forms these long, narrow islands that look just like this, and they're just basically sandbars. They're only maybe a foot or two above the water, very, very shallow, mostly sand. They get blown around quite a bit. Whenever there's a hurricane or a large storm, they can be flooded and erased and redeposited. But sometimes they're pretty well established, and people will build on them because you want to live on the beach. Here's Ocean City in Maryland. You see here all these beautiful hotels. If you go down to Daytona Beach or Palm Beach, those are built on barrier islands, as well as much as Miami too. All right, I'm going to pause right here and get you a chance to get up and stretch and get a cup of coffee and come back. And then when I come back and you come back and we all come back together, we're going to talk about rocky coasts.